All right, we're going to continue solving some rational equations here. All right, so let's zoom in on part C. First thing I want to do with all of these is, of course, find my domain restrictions. So I'm going to set each denominator equal to 0. So x squared plus 2x equals 0 and x squared equals 0. Now I'm going to factor the first one, so this is x times x plus 2 equals 0. So each factor is set equal to 0. And I'm going to solve. All right, now x squared equals 0. I still want to kind of factor it just partially because I want to see for my LCD what's going to happen here with the factors. So x squared, remember, is going to be x times x. So if I set each one of these equal to 0, it's the same x. So we've got a whole bunch of zeros here that x can't equal, and x also cannot equal -2. So my domain restrictions, x cannot equal 0 or -2. So that's the domain restrictions. Now, LCD. Your first fraction here had the factors of x and x plus 2. So I know I need x, and I need x plus 2. My second fraction had 2 single x factors. I only have 1 right now in the LCD. So I actually need to include a second x, which would make my LCD x squared times x plus 2. All right, so just be careful about that you include all of the bits, parts, and pieces, in this case factors, from your denominators into the LCD. So let's go ahead and use that LCD. So we've got x squared times x plus 2. And then we have another x squared times x plus 2. Cancel out what you can. Now, this may have been a good place for me to put x times x plus 2 because this denominator is x times x plus 2. So I know the x plus 2's can cancel, and this x will take out one of these two, but not both. So I sometimes will just cross out the x down here and cross out the power, which would leave me 3x. So 3 from the numerator times the single x that's left over here is that 3x. So this is going to equal, now this x squared can completely take out this x squared. So that would be 6 times x plus 2. I'm going to solve this. So 3x equals 6x plus 12. Let's go ahead and subtract 6x from both sides. So negative 3x equals 12. Divide both sides by -3. X is equal to -4. And I keep saying it, but maybe. The reason I keep saying maybe is I need to check this solution with my domain restrictions. So I'm going to zoom out here. Clearly, -4 is not one of my domain restrictions, so this is okay to have. So x does equal -4 with the domain restrictions that x cannot equal 0 or -2. All right, so that's part C. Let's go ahead and slide over to part D here. Ooh, this one looks like a lot of fun. Lots of fractions. All right, first things first, domain restrictions. So I want to focus on just my denominators. All right, and I'm going to set each denominator equal to 0. So x plus 3 equals 0, x minus 2 equals 0, and then I've got x squared plus x minus 6 equals 0. All right. So subtract 3, x equals -3, add 2, x equals 2. Now I want to factor this denominator. So I'm looking to see what multiplies to -6 and adds up to +1, which kind of conveniently gives me the factors that I already dealt with, right? This x plus 3 I've already dealt with here. And this x minus 2 I've already dealt with here. Now that won't always happen, but it's kind of nice when it does. So domain restrictions, x cannot equal -3 or +2. Those are the things that I would have to throw out of my domain. It's not possible for x to equal those, or else you'd get some denominators that are 0. All right, let's talk LCD. So I want to use every factor that shows up in my denominators. So my first factor would be x plus 3. My second factor, and that's from this first fraction, my second factor is x minus 2. And the nice part is this x squared plus x minus 6, when I factor it, it becomes these two terms. So no, you don't have to use them multiple times as long as each factor only shows up once in a denominator. So x plus 3 would be for this denominator and this one. X minus 2 takes care of this denominator and this denominator as well. So I'm going to multiply every single piece by x plus 3, x minus 2, x plus 3, x minus 2, and x plus 3, x minus 2. Now I want to go through and cancel out what I can to make all of the fractions hopefully disappear. And if I've used the correct LCD, those fractions will disappear. So x plus 3 takes out x plus 3, leaving behind -2 times x minus 2. So that's the -2 from the numerator, and that's the x minus 2 from the LCD that we didn't use or cancel. Plus, I'm going to use that 3 from the numerator. X minus 2 will take out x minus 2, but we still have x plus 3 left over from the LCD. Equals, there's my 5, right? That's the original numerator. But if I think about this denominator, it is these two factors. So this whole denominator will take out both of those factors. And what I'm left with is a pretty simple equation to solve. And yes, I know I said that's simple, but compared to the fractions we started with, yeah, it's a lot more simple. Let's distribute. So -2x plus 4 plus 3x plus 9 equals 5. I'm going to combine some like terms. -2x plus 3x is x. 4 plus 9 makes 13. Let's go ahead and subtract 13 from both sides. And I'm getting the feeling that's a -8. Yeah, that sounds good. So what I want to do is quickly double check, and we keep doing this every single time. Does that answer, or is that answer one of our domain restrictions? So let me zoom out. So -8 is what we want to check. Neither of these domain restrictions is -8, so we're all good to go. That is my answer. X is equal to -8. With the domain restrictions, x cannot equal -3 or 2. All right, I'm going to go ahead and close this video having done those two problems. If you've got any questions or concerns, please let me know. You can either message me